Welcome to your Algebra 2 10.4 video lesson. Today we're going to talk about probabilities of disjoint and overlapping events. Compound events occur when you consider all the outcomes for either of two events, A and B, which is called forming the union of A and B. Another compound event is when you consider only the outcomes shared by both A and B. That's when you form the intersection of A and B. The union or intersection of two events is called a compound event. Okay, so sometimes you have events that do overlap, and so their intersection has some observations in them. So here we've got the union of A and B. So it's everything that's in A and everything that's in B. Okay, that's the union. And then over here we have the intersection of A and B, and these are only the outcomes that are common to both of them. Okay, and so you can see here physically that A and B overlap, are considered overlapping events because they do share some outcomes. But there are some cases where your intersection of A and B are empty. Okay, there is no intersection that has anything in it, and these are called disjoint or mutually exclusive events. One occurs or the other occurs, but they never occur at the same time. So, it's important to understand these things whenever we're trying to calculate the probability of compound events. If A and B are any two events, then the probability of A or B, okay, the probability of the union, is the probability of A plus the probability of B minus the probability of A and B. Well, why do we have to subtract that off? Let's look. All right, so here, if we add the area of this circle A could represent the probability of A, and then the area of this figure B would be the probability of B. The issue involved is we've added the probability of the intersection twice. So we have to subtract it off once so that it isn't double counted. Now, when the two events are disjoint, like this one, there's nothing to subtract off because there is no intersection. So if two events, A and B, are disjoint, then the probability of A and B is equal to 0. So the probability of A or B is the probability of A plus the probability of B, because the probability of A and B is 0. So we don't really have to write that down. But remember, this is only if they are disjoint, also known as being mutually exclusive. There are no outcomes in the intersection. Okay, so a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a 10 or a face card? Well, being a face card means you've got a jack, king, or queen, and so that's certainly mutually exclusive from being a 10. So those are disjoint events, right? So here we have event A being a 10. We've got our 4 different types of 10s. Event B is being a face card. We've got our 4 kings, our 4 queens, and our 4 jacks. So the probability of A or B is going to be the probability of A plus the probability of B. So 4 out of 52 plus 12 out of 52, which gives us 16 out of 52, which reduces down to 4 out of 13, which is approximately 0.308. We did not have to subtract off the probability of where they overlap because there is no overlap. These are disjoint, also known as mutually exclusive events. Okay, let's look at this one. So a card is randomly selected from a standard deck of 52 cards. What is the probability that it is a face card or a spade? Okay, so if event A is it's a face card, we've got our face cards for hearts, face cards for diamonds, face cards for clubs, face cards for spades. Event B is that it's a spade, so we've got our ace and our 2 through 10 of spades, but we also have our king, queen, and jack of spades. So you can see here, king of spades, queen of spades, and jack of spades is included in event A, but also in event B. So we have to subtract off the probability of A and B one time because We're going to add it when we do the probability of A, and it's going to get included when we do the probability of B. So it will be added twice. So this 3 out of all our outcomes will have to be subtracted off once. So those 3 cards are included in this 12 out of 52. They're also included in this 13 out of 52. So we have to subtract off those 3 out of 52 one time. So we've got our 12 face cards out of 52 plus our 13 spades out of 52 minus the ones we've counted twice. And so we get 22 out of 52, which is 11 out of 26. So the correct answer is B. All right, now we're going to use the formula to do something a little surprising, okay? So we're actually going to use the formula for the probability of A or B to figure out the probability of A and B. Out of 200 students in a senior class, 113 students are either varsity athletes or on the honor roll. There are 74 seniors who are varsity athletes and 51 seniors who are on honor roll. What is the probability that a randomly selected senior is both a varsity athlete and on the honor roll? Okay, so event A is going to be being a varsity athlete, and event B is going to be being on honor roll. So we were told that 74 are varsity athletes and 51 are on honor roll. So 74 out of 200 is our probability of being a varsity athlete. 51 out of 200 is our probability of being on honor roll. And then we were told that 113 are either a varsity athlete or on honor roll. So let's find the probability of A and B using our formula that the probability of A or B is equal to the probability of A plus the probability of B minus the probability of the intersection. So let's plug in what we know. So 113 out of 200 is our probability of A or B, and that's going to equal the sum of 74 out of 200 plus 51 out of 200 minus the probability of A and B. So if we add the probability of A and B over and we subtract off the 113 over 200, we rearrange our formula so that we've solved for the probability of A and B. It's going to equal 74 out of 200 plus 51 out of 200 minus our 113 out of 200. Okay. So that gives us 12 out of 200, or 3 out of 50, which is 0.06. Okay, so that's the probability of being both a varsity athlete and a member of honor roll. So that's kind of cool because we think about this formula as a way of finding the probability of A or B, but in some circumstances, if we know the probability of A or B, as well as the probability of A and the probability of B, we can use it to find the probability of A and B. All right, so now you have some guided practice. So go ahead and do those. Pause the video, do your guided practice. Welcome back. Okay, now we're going to talk about complements of events. The event A bar, called the complement of an event A, and read as A bar, consists of all outcomes that are not in A, and the probability of A bar is 1 minus the probability of A. Okay, so let's use this whole concept of complements. When two 6-sided dice are rolled, there are 36 possible outcomes. You can see this here. We've got a white die and a red die. Find the probability of the given event. So for A, the sum is not 6. And then for B, the sum is less than or equal to 9. All right, so the sum being 6 is going to be given to us on this diagonal right here, okay? 1 plus 5 is 6, 2 plus 4 is 6, 3 plus 3 is 6, 4 plus 2 is 6, and 5 plus 1 is 6. So the sum not being 6 would be every other member of the sample space. So it's going to be much easier to do 1 representing 100% of the outcomes minus the probability of rolling a 6, a sum of 6, than it is going to be to add up all the other individual sums. So the probability the sum is not 6 is 1 minus the probability that the sum is 6. So that's 1 minus 5 out of 36. Again, you can count those 5 ways right here. 1, 2, 3, 4, 5 ways to roll a 6. So it's every other way except those 5 that we're interested in. So 36 over 36 minus 5 over 36 is 31 over 36, which is approximately 0.861. Okay, so let's look at the sum is less than or equal to 9, but we're going to do, if you look at that in all of our outcomes, let's find where it equals, they equal 9. Okay, so that's going to be right here. Okay, less than or equal to 9 is this diagonal and all of these others. Okay, so we could figure out those probabilities, or we can just do 1 minus the probability that the sum is greater than 9. All right, and if we count the number of ways that the sum can be greater than 9, there's only 6 of those ways. We look back over here. Okay, here is our 9. Okay, and there are 1, 2, 3 ways to roll a 10, plus 2 ways to roll an 11, plus 1 way to roll 12 for 6 outcomes that are greater than 9. So we can do 1 minus those 6 outcomes over 36. 1 would be 36 over 36. When we subtract, we get 30 over 36, which reduces to 5/6, so 0.833. All right, so let's use a complement in a real-life situation. A restaurant gives a free fortune cookie to every guest. The restaurant claims there are 500 different messages hidden inside the fortune cookies. What is the probability that a group of 5 people receive at least 2 fortune cookies with the same message inside? So the number of ways to give messages to the 5 people is 500 to the 5th power, because for each of the 5 people, there are 500 messages that they could receive. So it's 500 for the first person, 500 second, 500 third, 500 for the fourth, and 500 for the 5th. So 500 to the 5th power. Now, the number of ways to give a different message to the 5 people is, first person still has 500 options, but the second person only has 499 because they can't get what the first person has. The third person can only get 498 because they can't get what the first 2 have. Next person's 497, and finally 496. So the probability that at least 2 of the 5 people had the same message is 1 minus the probability that they're all different. So the probability that they're all different, none of them are the same, is the 500 times 499 times 498 times 497 times 496 over the 500 to the 5th power. And so that comes out to be 0.0199. So right around 2%. There's right around a 2% chance that at least 2 people will get the same message. All right, so you're going to do some guided practice now involving complements, including considering, well, what if there's only 100 different messages? What's the probability that at least 2 get the same if that's the case? And we will go over those in class next time. Thank you for watching your video and taking good notes. Please come see me if you need extra help. I look forward to seeing you next time in class. Have a good day.